Let's start with 9A. What page is A on? So we are on page 143. Number 2. A small data set is shown below. R is about 0.76. If you switch the two columns, does this change R? No, it does not. If you times everything by 2, does it change R? No. If you divide the y's by 2, does it change R? No. Oh. Did you hit yourself? Okay, number 3. Okay, so you add 3 to each value. Does it change R? No. You double the x's on 4? No. You interchange the last two values. Yes. Okay, it will change it a little bit. So as long as you do the same thing to every number or every column, it's not going to change anything. But if you switch the values, that will change something. 6. Suppose that the correlation between x and y is 0.73. Does the scatter diagram slope up or down? Up. Is it steep or is it not steep? We don't know. Right? 0.73 does not tell us the steepness. It just tells us the shape of the football. All we know is it's going up, and it's a regular football, maybe a slightly skinny football. If you multiply all of the values of y by -1, would the new scatter diagram slope up or down? Down. Okay, if you multiplied all of the y values by -1, what happens to the correlation? It just changes from positive to negative. But it's still 0.73, right? It's just going in a different direction. 7. 2 investigators are working on a growth study. The first measures the heights of 100 children in inches. The second prefers the metric system and changes the results to centimeters, multiplying by 2.54. A scatter diagram is plotted showing for each child its height in inches on the horizontal axis, the height in centimeters on the vertical axis. If no mistakes are made in the conversion, what is the correlation? 1. Right? If we graph height in inches on one scale on one axis and height in centimeters on the other, it will be a perfectly straight line. What happens to R if mistakes are made in the arithmetic? It's going to be less than 1. What happens to R if the second investor goes out and measures the same children again using metric equipment? So if I use a yardstick to measure your height and you use a meter stick to measure heights, is it going to be a perfectly straight line? Maybe one of these will let me. Are we going to get a perfectly straight line? No. Now this is a little bit strange. If I measure in inches and then you take my measurements and convert them to centimeters, we will get a perfectly straight line. But if I measure in inches and you use a ruler to measure in centimeters, why is it not going to be a perfect straight line? We're both going to round, right? Yeah, you're not going to end up with exactly the same. Are they going to be close? Yeah, the conversion, if you take my measurements and convert them, they're going to be really close to your measurements. But yours are going to be to the nearest centimeter or the nearest half centimeter. Or if you're, even if you did the nearest millimeter and I did the nearest eighth of an inch, they don't match up exactly. It'll be really, really, really close, but it won't be perfect. And number 10. 6 data sets are shown. The correlation is 0.8571 in letter I, and then in II the correlation is 0.7857. Find the correlations for the remaining data sets. So 3 has the same correlation as 2 because they're just inverted. The x and the y's are flipped. Okay, 4 has the same correlation as 1. What's the difference? What's the difference between 1 and 4? We just added 1 onto all the exponents. Or the x numbers, not exponents. What? Oh, Zane does that. 10. Okay. Column 5. 5 is the same as 1. The y's have just been doubled, so they'll have the same correlation. And 6. 6 is the same as 1. We just subtract 1 from the x and we triple the y. Same correlation.